Project 3.1.4 CHUMP, RAM, Address, and Accumulator. This is the final main stage of the construction of the 4-bit processor. In this stage, the memory units of the 4-bit processor were added, giving it the capability of remembering values and storing them for later use. This is the accumulator. It takes inputs from the F ports of the ALU, and then it produces outputs that go to the ALU's A ports and the RAM's value ports. The accumulator is a 74LS377D latch component made up of 8 independent D latches. The reason this specific D latch is used rather than any other D latch is because it's able to mitigate clock pulses when it doesn't need to take in a new value and wants to retain a value it already has. This makes operations such as if 0 and go to possible without changing the value in the accumulator, while the ALU value would be forced to change as a result. Clock pulse mitigation is connected to the enable pin, which comes from a signal on the control ROM. This is shown by the C flag. Additionally, as any other D latch requires, it is connected to the clock pulse, given by the purple triangle and the lines leading to it. With the accumulator, CHUMP is now able to perform back-to-back arithmetic and logic operations with the ALU, using the value stored in the accumulator as a comparator value or arithmetic value for the other operand. The address register is a typical D-latch chip with 6 independent D-latches at a 5-volt operating capacity. The address register is used to provide a one-step delay to any operation involving RAM, which is store to or read from the base instruction set. This delay is also given to the RAM's read/write signal. As an example, if the instruction read 8 were to occur on CHUMP, the value 8 would be stored into the address register from the multiplexer from whichever source it came from on the yellow line to the address register. On the clock pulse, which triggers the next instruction, the value would be shifted out to RAM. Then, whatever value is stored in RAM at address 8 would be sent on its outputs through the multiplexer and into the program. For a store to instruction, the address location would be sent to the address register, shifted out on the next step to RAM at the same time as the accumulator releases its value to be stored to that address. At first, it might seem that the accumulator releases its value to RAM a step before it receives the correct address location, but accumulator actually sends the value through the ALU and comes back as it was to be stored to RAM in the next step. RAM stands for Random Access Memory and is used to store values for long periods of time. The device is set to read mode for all actions except for store to in the base set of instructions. In this mode, it reads the address value sent to it from the address register and outputs the value on its output pins to the multiplexer. However, for the most part, the multiplexer does not send them through. When it is set to write mode, which is for a store to action, the RAM reads the value that is set to it on the D pins and stores it to the address which is defined on the A pins. The output pins from RAM are inverted open collectors, so they have to be pulled high and they have to be put through a logic inverter in order to be read properly. The addition of these parts allows CHUMP to perform any operation now that it is able to maintain short-term memory from values produced by the ALU and also maintain long-term memory for values stored to RAM. Thanks for listening.